Hello. Today we're going to work with a minimum-maximum problem. A box has a square base and no top. The total area of the sides and the base of the box is 48 centimeters squared. Find the dimensions so that the box has maximum volume. So we want to look in this question and see what information we're given. We're told that the box has a square base, that it has no top. So it's only going to have 5 sides. The base and then the 4 sides around, because there's no top. Now all of this total area, meaning the sides and the base, is only going to add up to 48 centimeters squared. This is all the area we have to work with. Now with that area, we want to find the dimensions of the box so it has maximum volume. We're trying to make the largest box possible, given that it has no top and 48 centimeters squared of material to work with. So the first thing we're going to want to do is draw ourselves a picture. So we have a box that will look something like this. It's going to have a square base, which means that we can label the base as x and x, and it's going to have a certain height. I'm going to label that h. Again, when we're doing a minimum-maximum problem, it's very important to label the variables as variables, unless otherwise stated. If the question has a number that stays constant throughout, we can label it with that number. But if there's a chance that it might change, we want to leave it as a variable. Now here we have x, x, and h, and we need to relate that somehow to the volume. Well, the volume of a box is always going to be given by the length and width and height all multiplied together. So the volume of our box will be x squared times h. And this is what we're going to want to maximize. But we can't maximize it just yet because it has 2 variables, and for most minimum-maximum problems you want to get it down to just 1 variable. So we need to think, what other information are we given? Well, we're told that the surface area, which would be x squared plus 4xh, the x squared coming from the bottom of the box, and the 4xh coming from each of the 4 sides. Now this surface area has to be equal to 48 centimeters squared. So we need to use these 2 equations and substitute the surface area into the volume for either x or h. Now, judging by the way our question is set up, it looks like it'll be easiest to substitute for h, because if we see there's just an h and an h, then we should be able to solve this equation for h relatively simply. If we look, there is an x squared and an x squared, but if we solve for x squared, we'd still have an x term, and you can try it on your own to see that it's much more difficult to make that substitution. Now going back, we want to isolate for h, so we're going to get 4xh equals 48 minus x squared, or h equals 48 minus x squared all over 4x. Now we're going to substitute that in for volume, and so we'll get that volume equals x squared times 48 minus x squared all over 4x. And of course we can make the simplification here by canceling one of the x's. Now if we look, our volume is just in terms of x. We're going to need to clean up the equation a little bit, but we can see that volume is only in terms of x, so we're going to be able to differentiate it. So here I have volume written as 48x minus x cubed over 4. I multiplied in the x. And we're going to take the derivative with respect to x, which will give us 48 minus 3x squared all over 4. And we can see that a 3 will factor in the numerator, and we'll be left with 16 minus x squared over 4 which again, we can factor to 4 minus x and 4 plus x, all over 4. Now that we've taken our derivative and we've factored it nicely, we need to see, what does the sign diagram look like? Where is the function increasing? Where is it decreasing? Where is it going to have the maximum that we're looking for? So if we draw the sign diagram for v, we're going to have a 0 here at 4 and a 0 here at minus 4. Now if we take a test value, say 10, when we plug in 10 into this equation, this is going to be overall negative, this one will be positive, and the 3 and the 4 will be positive. So overall we'll have a negative sign, and then positive and negative. This means it's decreasing, increasing, and decreasing. So we're going to expect to find a relative max at 4. And it's important that we note here that at 0, that's the lowest that x can go. All these other values, they're not in the domain. X has to be bigger than 0, and that makes sense, because if x was less than 0, our base of our box would be less than 0 and we wouldn't have a box. So x has to be bigger than 0. That means we're going to expect to find a relative max at 4. So we need to now find the other dimensions of the box. Going back, we know that h was equal to 48 minus x squared over 4x. Substituting in for x, we find that h is going to be equal to 48 minus 16 over 16. This means that h will be equal to 2. Now we want to answer in a sentence, so the dimensions are 4 centimeters by 4 centimeters by 2 centimeters. The 4 centimeters for the base, 4 centimeters for the other side of the base, and 2 centimeters for the height. These are the dimensions that will maximize the volume of the box. Thanks for watching.